Yes, it's the next speaker is actually Sean Laval, technical head of IoT at Comsol Networks, and yes, and the title of his presentation is Low Power Wide Area Networks, and how that will enable the global IoT. Let's just give Sean a minute. Thank you. Please give Sean a round of applause. Thank you.
Thanks. We can maybe talk about the ethics afterwards, but I think everyone's eager to get to lunch. So I'll make it a fairly quick and light presentation. So just a brief introduction. My name is Sean Laval. I'm technical head of IoT at Comsol Networks. I currently oversee the deployment of Comsol's low power wide area network, which is a national network, LoRa network that we're setting up around the country. So what I want to focus on today, we've seen a lot of good presentations and a lot of good data around the upper layers. And everybody agrees that the upper layers are where the real business value lies in the IoT. But what I want to talk about today is the lower two layers, which sometimes don't get enough attention, but arguably, if businesses don't get these bottom two layers right, they can be the most costly to rectify down the line. And I think I also want to drive home what the issues are that have been resolved and are being resolved by updates in technology, which is really driving through IoT connectivity in a way that we haven't seen before. So I think that this has been widely spoken about during the conference, how we've moved from end-to-end to Internet of Things. A good example was one I brought up yesterday about smart watches and how they're being linked to insurance companies through centralized data storage and organizations that did not previously consume that data finding value in that data. So what I really want to get to is what is driving this rapid IoT growth when we look from the bottom up. So essentially, the unprecedented access to information and shared data storage is by far something that is really driving this industry and creating opportunities that weren't there before. But from the bottom layers, what we're seeing is economies of scale from sensors and lower costs is really what's bringing up opportunities to connect devices that were not financially or practically feasible in the past. Only 10 years ago, sensors were mostly the most expensive part of many electronic systems, whereas today it's almost a commodity. And this has been largely driven by the smartphone industry. In addition to that, the lower power consumption of semiconductor components and the higher integration has brought down power consumption and made it much easier to get into the market with world-class products. So all these factors together are really creating a perfect storm for opportunities to connect physical objects into the internet, which is really the basis of where all this value is generated. So just a brief description. We always talk about devices, and to many people it's obvious what a device is, but what I've found in engaging with industry is to some people it's not obvious what a device actually is. And essentially, any Internet of Things device, especially a low-power device, consists of 4 components. It's a battery, a sensor, a radio module, and that radio module often incorporates a microcontroller, or they can be 2 separate components. And then, of course, we get the network layer and the application layer, which we've all seen quite a bit of during the conference. So what I want to get to is what's generating all this data that we're seeing, and why now? So essentially, a lot of these things have been generating data for years, and some of them now are only beginning to become connected, but why? Why now, and why weren't they being connected 5, 10 years ago? And essentially, it comes down to the fact that the cost of deploying a system should never exceed the value that that system can bring to an organization. And value is measured in various currencies, if you like, depending on what industry you're targeting. In the medical industry, it's often measured in quality and longevity of life. In the consumer industry, it could be measured in convenience. In the industrial enterprise, it's most often measured in monetary terms. So what I want to do is just do a brief case study of this. It's a 2-minute video. Some song.
The shopping cart. Its modest looks conceal a precision-engineered marvel. This humble machine is so much more than just a basket on wheels. Over 100 lightweight parts haul up to 350 pounds of groceries, 75 yards of toughened steel cage coated in Teflon to increase its endurance, snap-on bumpers strong enough to survive 30-mile-an-hour impacts, anti-static tires made from the same material as roller coaster wheels to prevent shocks, and freewheeling but forward-facing rear wheels inspired by a car's effortless steering, all engineered to survive 35,000 shops in its lifetime. Every cart must be tough enough to haul heavy groceries for up to a decade. Each new cart costs around $100. Store owners are keen to keep hold of every one, so some have an ingenious trap to trip up potential thieves. As a cart crosses the shop perimeter, a cable hidden underground wirelessly activates a motor in the wheel. Smaller than a matchbox, it cranks a set of gears that force out special teeth, which lock the outer wheel in place. The teeth prevent the wheel from turning and stop thieves in their tracks.
Great. So technology solved all my problems. Where do I start? In fact, in my 10 years of doing GSM development, I was asked to solve this particular problem several times. But there was one particular issue that always came up. So let's do a bit of the maths. I know we're getting close to lunch, so I've done it for you. So if you look at 100 carts in this case study, and we take a service life of 5 years. They did mention 10 years, but I think a more realistic service life would most likely be 5 years for that cart. And we take 20% of that cost for that security device away from that cost of the cart. What we see is that there's a total security investment of 26,000 Rand additional. And for that additional value, we could get essentially 25 unsecured carts. So basically what it comes down to is unless we're losing one cart every 2.4 months, it really makes more sense to buy an extra 25 carts and just let them get stolen. And this is really the problem that we've faced, is everybody wants to track things, but it really hasn't made sense in terms of business value. And the IoT is changing that. So imagine now that same cart could be tracked around a shopping mall with iBeacons and see where that cart goes to other shops, creating cross-marketing opportunities. Imagine that same cart could give its location and reduce operational time to retrieve those carts from the mall. So there we're seeing the business value shift again in favor of this model. Even though it's not addressing the primary concern, it's certainly adding to the business value. But it relies heavily on the cost of the hardware, on the cost of the connectivity, and if we have to change a battery, it significantly increases the cost, and that breaks the business model as well. So essentially, this brings us to where we are now, and what I want to really touch on today, which is low-power wire technology. So analysts state that 86% of IoT devices consume less than 3 megabytes per month, and 76% less than 1 megabyte per month. So what we've been doing in the standard end-to-end world is opening these big data pipes, which consume huge amounts of energy, when really what we want to send is a little drop of data. So what is this low-power wide area world? We've heard it mentioned several times today, and I think what I want to get across today is, in as unbiased a manner as possible, who the players are in this world and what you should be looking for in terms of different solutions. Because no one of these players is going to address the entire market, I believe. I think that there's space for everybody depending on your particular application. So where does it sit? Well, in terms of our standard technologies that we know, it sits here. So a low power, wide area. And it's not for free. It's not that physicists have created some magic formula or magic transceiver. Essentially, what we've done is we've sacrificed data rate to get into that quadrant. And that applies to every low-power wide area technology. But in the world of IoT, data rates are not a primary concern, not as much as cost, range, and battery life. Cisco Systems predicts that by 2019, 29% of wide area wireless connections will be using low-power wide area technology. So the biggest organizations in the world are taking this very seriously. And they basically all have several common factors about them. Some of them I mentioned, but there's a few more here. So where's the sweet spot? Well, here we see where it sits in line with some of the more familiar technologies. So when you get to the lower end, low-value tracking, smart metering, agriculture, lighting, parking, things that basically fulfill these criteria, then you should be looking at low-power wired technologies as a serious option. I'd say if you have 2 or 3 of these, then definitely this is the technology for you. So basically, they can be broken up into 2 separate segments, low-power wired technologies, synchronous and asynchronous. Synchronous is very analogous to how, well, it is how GSM networks work now. A device connects to one tower, and it's time-scheduled communication. Essentially, the network schedules that communication. In asynchronous, it's the other way around. The device schedules the communication, so it controls when it wakes up and sends out the data, and all towers in the vicinity pick it up. It's just a high-level view, but depending on your application, this is something to keep in mind. So I'll be focusing a bit more on LoRa as it's the technology we're using to illustrate the asynchronous nature of it. So what does a low-power wide area network look like? Well, essentially, there's the devices, there's the gateways, and they transmit to one gateway, but when they transmit in an asynchronous network, all the gateways are picking it up. So if there's catastrophic interference in one, it's still being picked up by other towers. And that's really how you're getting carrier-grade quality of service in a license-free spectrum. Due to this feature of it, through to a backhaul and through to a central network server. And that's really how asynchronous networks need to work. So all towers send the data in, it aggregates the strongest data, and that strongest signal is routed through to the application layers. So how do you get to capacity? So when we talk about millions of things in the Internet of Things, these networks need to be able to support hundreds of thousands of devices in a very small area. So in the case of LoRa, what it does is as devices get closer, the network says, whoa, I can hear you quite well. You don't need to shout. And you can speak much quicker because your signal is very strong. So what we have is as it gets closer, it's on air for less, and it's talking softer. But as it gets further away, it speaks for longer and slightly louder. But of course, as the network densifies, really what we see is that. So if you design for the worst case where it has to shout, chances are that it'll be positioned somewhere where it can actually talk very softly. And the consequence is that if your engineering teams are designing devices for its worst case, there's a good chance in an asynchronous network like LoRa that you'll get 10 times the battery life that it was originally designed for as this network densifies. So just a brief talk about how LoRa originated. So it's an alliance-driven protocol, and it's an open protocol. Here are some of the major industries that are backing the LoRa Alliance. In fact, the LoRa Alliance consists of over 450 member companies today, globally. And there's several national networks that have been rolled out throughout the States, Europe, and Asia. So what's the benefit of a alliance-driven open protocol? Well, here are 2 lesser-known technologies that have a similar model. So really, it is a proven method of driving technology into the market and ensuring longevity of the technology. And in fact, Makina Research, who was bought off by Gartner Research at the end of last year, predicts that open standards will, in IT deployments, will accelerate growth by 27% and reduce deployments by 30%. Okay, so I'm nearly done. I'll finish off with a case study, in fact. So this was the Cape Epic last week. We partnered with Dimension Data in the Cape, who is a major sponsor of the Cape Epic. And the brief was simple. They had dead spots in the coverage. They've been using traditional GSM technologies. What can we do for them? So we said, how can we help you? And we partnered with a local wireless service provider down in the Cape, and we set up 3 gateways that were solar powered. In fact, the one site you had to hike up to get there. You couldn't even drive there. With an ISM backhaul, very low bandwidth ISM backhaul. And if you look at the device that we put up there, so they took a GlobalSat device, which is about the size of a matchbox. We have it on our stand if you want to take a look. They put an extra battery because they wanted a transmission every 10 seconds. So it wasn't a true low-power device. They wanted the technological and the range aspect of it. And there we have the solar-powered panel that they put on the front. And what they did is they streamed it back to the Tour de France truck. So this is the very same truck they use in France to aggregate all the data from the Tour de France riders and stream it out to the broadcasters. So that full system was there, and they were analyzing this data in real time and making sense of the data, ultimately to create real business value for the people who are watching the race, loved ones, as well as advertisers. In fact, there was a good case study in the Tour de France where, because of the data they were displaying on the screen, what was happening, and because of bringing this data in, the one stat said about the one Tour de France rider that he had the speed record for cycling. It was 102 kilometers. And what we saw is other cyclists in the lead pack over the next few days taking snapshots of their speedometer and tweeting it to the other riders, and that data was then retweeted to other riders. And what we saw is the Internet of Things creating social awareness and bringing that sort of marketing play into their business value. And in fact, the organization that runs the Tour de France reported a 57% increase in social media uptake since they implemented this system. No, it wasn't LoRa-based, but we can get into that technology later on, well, if you want to know about it. So this was our network that we set up in the Cape. That's the real tower on the right there. And it performed as predicted most of the time, except for a couple of cases where it really exceeded our expectation. So this is real data from a matchbox-powered device that transmits at the same power output as your garage door remote, getting 38 kilometers at line of sight, and at minus 16 dBm, or dB. So the consequence of that, so minus 16 dB is in fact 40 times less than the ambient white noise. And that's the benefit of spread spectrum technology, and really is the foundation of LoRa's carrier-grade capability and range. So just to sum it up, at Comsol, we believe that the 2 pillars of the connected world of tomorrow are reliable high-speed data and low-power wireless connectivity, and we are positioning ourselves through our 28 gigahertz national network, as well as our low-power LoRa network to address both pillars of this industry to create maximum value. Thank you for your time.